Okay. Okay. Today we are going to talk a little bit more about the data types. So we are going to talk a little bit more about the string class. What is the string class? String builder class. What are the primitive wrapper classes? And what are the final fields? And what are the enumeration types? So the string class stores a sequence of Unicode characters. What does it mean? So the character itself is a primitive type, but the string is not a primitive type. So it contains and store uh, a sequence of UTF-16 encoding. What does it mean, UTF-16 encoding? So UTF-8 contains like 8 bits, but UTF-16 contains 16 bits. Now for the level of this class, I just need this amount of information. For more information, you can just Google it that what is the UTF-16 and UTF-8 is. But the important thing is that we already put the characters in a single quotation, but we include the string is a string variable in a double quotes. And values can be concatenated with plus and plus equal in the string classes too. The string objects are immutable. So what does it mean? It means that, again, like the previous lectures, we cannot check the equality of the string class with the equal function, equal operator, but other thing with the equal operation. So let's just think what it is. So we are in lecture 11. No, last folder. Lecture 11. The package info file. That is, I want to add it to the Git. To add it another package under my own name and another class that is lecture 11 source. Okay. And I will try to do it. Okay. And this is the string class. Okay. Think that I have a variable that is in a string. So this is the way that we define in a string. We know it in advance, but we are going to talk a little bit more specific about the string and take that it is like Jim, the value of it. So the string is enclosed in double quotes. Let's just print it out. And say like hi. This is how we concatenate in a string with the name. Okay, let's try it.
Professor, serious question here. When we declare variables, are we making string always uppercase S since we're getting 10% off on assignments for?
You have to do string. It won't let you do it otherwise.
All right.
That's just how the.
About the camel casing and the Pascal casing, Kevin?
Right, because int and double.
Yeah, it's about the convention. Yep. Yeah, that's part of the convention part. That if you just code like this that we are coding in the class, you are good actually. No.
Cool.
Like the convention is just like this, like the Pascal casing and the camel casing. Everything is like this.
It's because string is not a type. It's like an object.
In Java.
So you mean, oh, you mean this part?
Yeah, the
I-
variable.
you're asking about the you're asking about the assignment. Yeah, the string is not a primitive, okay? So we are talking about the string class. In Java, we don't have a primitive type like this string, okay?
Mhm.
But because it is a class, so it starts with a capital case.
Understood.
And yeah, so this is that because of that we put a lecture for it. You know, it's very important to know about it. So the string is a class, and it's starting with a capital case here, and we are using a variable name here, and this is the result of lecture. Hi Jim. Let's put some other here. So think about that. We are just doing some greeting here. And we put the greeting is equal to hello. And what we want to add to greeting is just a space. This is a space. So this is how we add something at the end of the string. And then I want to add plus again word, just like hello world. Everyone knows this, but I'm going to do something about it. And let's just print it. Greeting. Let's run it, find out what's happening here, then let's discuss it. Okay, hello world. This hello world, we just concatenate again some string to the first string. But what's happening over here is that for the first time the greeting is hello, okay? Then when we add some space at the end of it, it will instantiate another instance of string class that has the lengths of hello, the characters of hello, and the characters of this part, that is 1. So 1, 2, 3, 4, 5, and again a 6. So it will instantiate an array of characters that has 6 elements, and then will point to this new instance, and then omit this reference. And when we add another word, another part of the phrase to it, the word, again, it will instantiate another instance of the string class, and add the rest of it to the end at the end of it. And then again, delete this reference. So the greeting, when you are concatenating the string to another string, is not the first string that you had. It's another one. And the first string is not there anymore. So that's the important part of it. So it will instantiate a new array of characters. So the string class has many methods. I'm not going through all of them. I'm just mentioning some of them. The important part of it is about I just categorize them in like some category. So it's about the lengths, how you can take the lengths of the string just with the string.lengths. So it will be like just this.
Professor,
Go ahead. You
if
can
you're
see
not
it?
going to go over it, it's not going to be an important part of our homework, right?
This part?
If you're not going to go over something that's like part of the lecture, it's not going to be an important part of the homework, right?
No, it's not a part of your homework assignment. You mean the project? You mean, huh?
Any later homework, like if you're not going to go over something for us for a part like you're not going to go over all these methods, so we're not going to have to worry about them for a homework, right?
You're not going to be, you don't be worried about that. You should know about them. It's just about to use them. You just should know about that, how to use it. Okay.
Okay.
It can be used in the further assignment. I don't have any idea about them because I didn't make them yet. But there are. I'm going to go through them all. I mean, like, what are they doing? And you'll just find out. If I just use one of them, you'll find out that how you can use all of them. You know, like everything. Yeah. So the length is just using like this. And when you want to take a string value of a non-string thing, like an integer, you should just, for example, take it like an integer, and it is like something like count is like 1, and then you want to take the integer, a string value out of it, and the value integer.
Sir, for the greeting, do we include in our program?
You are including your program?
No, for this for the greeting. Since someone asked about greeting, do we include in our program? No, it's all right. Go ahead. Finish.
I can't follow you. You know what you asked.
Oh, you good. Go ahead. Finish.
Okay. So just let me. Okay, for the value, I'm just going through them. No, it's taking like so much time here. It's better just to know what. So if you have like an integer class and you want a string value of that integer class or double class or other type of class like short anything, you can just reach the value of the string value of that with just this method, value of. And for creating new string or strings from an existing string, if you want to concat two strings, you can use the concat. If you want to replace a string with another string, you can use the replace. If you want to make every letter in a string to a lowercase, you can use just dot to lowercase. If you want to change it to the uppercase, you can just use it to the uppercase. So the usage of this lowercase or the uppercase sometimes it's in the web applications, for example, when you want to compare a username with another username, because the username is not case sensitive. So you should just make it to a lowercase or the uppercase, then compare it to with the database. And if you want to trim like the space or the semicolons, everything from the first of the string or the end of the string, you can use the trim method. If you want to split the string according to a specific character, you can use the split. And for formatting in a string, like what you had in printing, in printf in the C, you can use just a format. And for extracting this substring from a string, if you want to get the character at a specific position, you can just use the character add. And if you want a substring of a string, you can use from a specific position or and to the end of it or wherever, you can use the substring. For testing the substring, it means that if in a string has some specific value, you can just use and all of these is, so this is returning a boolean and a string that contains something, or end with something, or start with something, or at the middle of the string, at the index of something, you have a specific character, or the last index of a string is a character, or is in a string. It has two orders. So for comparing to a string, you can use the compare to, and for comparing and with ignoring the case sensitivity, you can just use the compare to ignore case. And if you want to check that the string is empty, you can use this function, is empty. If you want to compare two strings together, you should use the equal. If you want to just ignore the cases, I mean the lowercase or the uppercase, you can use the equal is ignore case, equals ignore case. But we have something special in the equality for the strings. So suppose that we have a string named S1 and we put I love in it. And then I add some Java at the end of that S1. So what we have now, we have an array of character that is I love Java. That is the string 1. And suppose that we have another string that is I love Java. And the first part of it is I. And the second part, I concatenate the love Java at the end of this 2. And then suppose that I'm going to compare these two strings with this S1 and S2, just with the like equal operator. What will happen is a false result. Why? Because these two are the classes and they are immutable. So because they are referring to two different objects, so they cannot be compared with the equal operator because they are not primitive first, they are not mutable too. So we cannot use the equal operator. What we have, as we learned in the previous lecture, we can use the equals method, that is the built-in method in the Java. So this method will check the value, each value element-wise, that this one with this one, this one with this one too at the end of it. So, and it will return a true. Why? Because they're really equal. Although they are two different objects, but the value of them are equal, and it's important for us. So what will happen here? This equal function will operate a for loop over here, for checking that if this function is equal to them. So what is going on here? It's just defining like this. It has like in a string that is S1 like something, another string that is S2 that is something, and again equals will have like something like this, like for the body of the equal function is like a for, and first you check that if, for example, I'm not developing all of it, that the length is equal to S2 the length. Okay, then continue, for example. What is the length? Is one of them. The lengths are one of them. So S1 the length. So S1 the length F, and there will be an equal here, a boolean that is an equal again, and it is false for at the first of it. If S1 dot caret I is not equal to S2 dot caret, for example, caret I. So again, it will be is equal this to nothing. So it will be like, again, it will be equal to the false. Here will be true. So the first part is true. If the loop finished and the equal is not changed, then the equal is again true. So this is what the equal function of the string class is doing. So what we need is that, okay, this equal function is going to lower your performance, reduce your performance so much. So what we can do is that making the string class mutable. So what makes it mutable is the intern method. So when you use the intern method, you're telling Java that this string is mutable. And I define another one to just leverage the equal operator instead of using a method that is going to reduce my performance. I need to implement the another embed method that is going to help me for the performance, because we are doing so much like comparing sometimes. So we will use this part. Okay. So instead of this, just develop it to know what's happening here. And this is the S1 and S2. I know. Okay. 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 So this is print and this out. Okay. And if equal, they are equal. So now we're done with this part. Let's just use another part. Maybe the enter. Now let's just use the S3 is equal to S4. So instead of this, just develop this. And first I got, let's just compare them together.
Would you be able to go back through this part? Because I feel like you went pretty quickly and I think I missed something.
I will just let me finish. I just want to show they're not equal. Let's try it first, then I will go through it. So I should have they are not equal, they are not equal. Then I use the equal method that is not very high performance. Then they are equal. Then I use the enter method, and this enter method is going to give me the leverage of using the operator, equal operator. And again, it's going to say that it's equal. So what is enter doing? So Kelly, are you good now?
Could you go up just a second? Okay, thank you.
So what enter method do is that having an object that is referring to a specific memory that Java knows where is it, and then when you are using the, for example, S1 and S2, and you are using the same value for it, it will refer to that value. So it won't get another more memories from it. So so let's go to converting part. Converting non-string types to string part. So we often need to convert non-string types into strings. For example, converting a primitive type, or converting a non-primitive type like fly class. So what we can use is that from a string class, we have a specific method named value of, or override to handle most types. For example, think that I have an integer here. And I want to convert this integer to a string value and then store it in a string. So I can use this string class, and the string class as an extension method that we can access it like this, just like this. Look at it. String dot. So these are all extension method of the string class. So it can take that it has like many overloads, like value of an integer, taking an integer, character, long, float, double, boolean, and object. So it can take an object to an array of character, with offset, and many things. So I just want to use the integer overload of it and send the I value to it. Okay. And then I want to just print it. The val is val. So the S value is just reading. So what next is the conversion often happen implicitly. So most of the time you don't need to use this value of. Most of the time the extension method that is for the output string and the input string streams, they will implement this functionality for you. So you won't have any concern about it. Like this time. For example, you have an integer I that is 2 and another integer that is j that is equal 3. And you want just to take the result of them, that I times j, and put it in the result, and then just print them all, that what was happening. Let's just check it. Everything is going to do like implicitly. You see, I didn't use the value of, the string value of, although that I could, but there isn't any need. So it will be a redundant coding over here. Another important thing is that the class conversions controlled by the class to string method. When we want to convert a class to a string, normally you won't have a good result out of it, because when you just use the toString method, like for the fly class, so let's just take the fly lecture to this lecture. I don't need the rest. If I need, I will take copy. Copy. Then paste. Enter. Edit. So does it have any dependency? Yeah, it has a passenger dependency. So you need the passengers also. Okay, passengers. And the flight, I don't need this passenger. And I have it in this package. Okay, how about this package? I don't need anything. So in the flight class, I have two basic properties for knowing the flight. Now, one of them is the flight number, the other is the flight class. So when I want to access to a class and find out which flight it is, I want to have something, and what can it be? It will be the number of the class, or it will be the class of the number of the flight, or the class of the flight. So for this purpose, we can develop a toString method that is part of the object class specification, that we can override it for it. What we do is that just override the toString method for each class that we want to have a string value of it, and then use the mechanism that we want to print the class, to print the property of the class that is important for us. So let's just do it. So when you want to develop a toString value over here, what you need is that, just let me close everything. So these are all the, so what we override from the class here, so This is in the object.java, you know. So I have another thing too. In object.java, I have the toString too. I have the colon too. So I'm developing the toString part now. So another override, it will be the toString. You see, I just here it is. And then it will ask you that which part of the properties you want to add into the toString method. I want to say that, okay, just the character and class number and the class the flight class, and to develop this for me. But I don't want this embed implemented thing that is providing by the IDE. What I need is that implementing my own toString method. I want to say that if the flight number is a number, just print out just return the flight number for me. Otherwise, just give me the flight class, because I don't have the flight number now. So it will be like this. So you can use the built-in method, or you can develop it yourself. I use the built-in method first to show you.
Can you show us how you got the override with the IDE?
You want me to show it again?
Yes, please.
Okay. It is just like this. So you just print like toString. So the toString is a method that is existed in the object class, and it is overridable. Okay, like I told you in the previous lecture. So I can override it, and when I want to override it, it can be generated for me by the IDE, and I can choose which property I want to add to this string part. I want just to add like the flight number and the flight class. As you like this, look at it. Yeah. So let's just use this first, then change it. Okay. I'm adding a flight here, and the flight I'm going to name it as a O flight, and that is a new flight, and the flight number is 175. And then I want to just print this flight. What I can do is that O flight toString. And I didn't assign any class to it. Okay, so I didn't assign any class to it, and the class is C, for example. But I don't have any constructor for it. So let's just develop it. Okay. So you see the flight, it's showing that this is a flight class. The flight number is 175, and the flight class is not assigned anything to it. So I don't have anything. But I don't want this type of a string as a result of the toString from the O flight class. I want another implementation of this. So I comment it, and I develop my own toString. If the class, so the flight number is more than 0, then return the flight number plus flight number. Otherwise, if you don't have it, return flight class plus flight class. And then, so I return in both conditions. So now look at that. Instead of this, I have the flight number is 175. So
Sorry,
that
can
was,
you go back?
yes. This is the built-in
Okay, got it.
that is developed by the Java. I mean by the IDE. This is the customized that you yourself develop. So the next part is the string builder. So the string builder is a class that provides mutable string buffers. For best performance, you can use the precise buffer for the string builders. But if you don't care about the performance, you can just use it as the like on-the-fly object, and it will grow automatically if needed. So basically, it's a string, and it will give you the leverage of some functionality. Most common method of this class is append and insert. So append, it will add something at the end of the string. So you have a string and you want to add something at the end of it, you will use the append function. And if you want to insert at the middle of something, you will use the insert functionality. Use the toString to extract the resulting string. If you want to take the resulting string that you built with the string builder class, you can just use the toString method. How? Suppose that we want to have this. I flew to Florida on flight 175. So I want to use the string builder class. So how can I use it? Is that, let me put it here. I will go to the lecture. So this is the string builder lesson. So first I need to make an object from the string builder, and I call it this B. That is new. So this is not a good convention. So the O string builder. Okay. The new string builder and I already have the flight here, or flight 175 here. So my flight, this is my flight. So let's make a my flight over here. This is my flight. And what is my location? My location is in some other value that is Florida. And I want to append everything together as a one string. So I have a location in another value, and I have the flight in another value. And then, so I can just use this, the O string builder dot append. What I want to append, first, I want to append that there isn't anything in it. I want to say that I flew to where? Space. Again, my location is O string builder dot append the location at the end of it, and then O string builder dot with what? So with which flight I want to go. I need a preposition over here that is the, I can use on. And then I can use the O string builder dot append again. So I just send in my flight class object to it, but my flight object, this append will look for the toString method in it and use the toString method of the my flight, and will use the, for example, will be the number of the flight. And how I can extract the value of all of it, I can just say just sp dot to string, and I can just print it like this out.
I have a quick question.
Go ahead.
Couldn't you just do like print out and then just call StringBuilder?
I doubt it, because if you it will use the to string. We can use it, but it will reduce the readability of your code, you know, because we already use it for the append. You see, you can use it because if you look, the print line will look for the true string of an object. But you know, it will reduce the readability of your code. Okay.
Okay.
It's okay, but you can use it. So again, suppose that I want to insert something at the middle of something. Suppose that I want to add a time at the middle of this string, a builder that ends the time that I fly will be the 9, and so I should find the position of the time. I will look for it, like I will put it in the pose. I will put it in the pose, and it will be the StringBuilder dot length. How much is the length? And minus the on dot again minus. So why I should minus? Because I want to go from at the end of it to the middle of it. So I will have the length of on and another length of my flight dot to string the length. So I have the position of the where I should put the time. Then I will put in the StringBuilder dot insert where I want to insert it in this position, and where I want to put the at space, and after that, again I want to add. So I add like 4 characters here. 1, 2, 3, 4. So the StringBuilder dot insert the position that I calculated before plus 4 characters that I add here. Put the time there, and then so the insert will just when you use the insert, the StringBuilder will automatically grow, and you put at the middle of the string there. So everything has not changed. The rest of it is there. So I can just use the message now. So I will put it in another string here, everything, and this is, I call it a message, and I can put the StringBuilder dot to string in it, and just print it out. Message. Okay, I add the time of the flight into my string. So so here I didn't define any capacity to this StringBuilder, but it has the capability of that too. So I can just use the 40, for example, here, and you can assign this. Okay, let's go to the next part. So what we have in the classes, what we want to use to say here is that comparing the classes with the primitive type, what primitive type has and what classes have here. The classes provide convenience for us. What they have is a common interaction through the object classes, and there are some fields and methods specific to that type, and it incurs an overhead cost when you build a custom type that is a class. It will give us some overhead, but we don't have this overhead in the primitive types. What we have in the primitive types is that we cannot treat it as an object. We cannot treat them as an object. They cannot expose the fields or methods, but they are lightweight. Okay, what can we do when we want to add all of this? So we want to have an object that is lightweight, has some field and method specific to the type, and has some common interaction through the object classes. What in Java language they come up is building some middle classes that we call them the wrapper classes, the primitive wrapper classes. So the primitive wrapper classes have some capabilities and the overhead of the classes. So they have the overhead of the class. So if you use the integer from the wrapper classes, it will have some overhead for you. And again, they will hold the primitive values. So let's go to the hierarchy of the primitive wrapper classes. What we have is that, okay, we want to have some primitive wrappers. So what we have is that we have an object class that every classes are going to be inherited from it. What we had in primitive values, we had a character, the boolean, and the numbers. Again, here we have these three categories too. As you can see, the character is starting with the capital letter, and the boolean is starting with the capital letter here too. All of the wrapper classes of the number have the base class from the number class. And so all of them are inheriting from all of the wrapper class of the numbers are inheriting from the number. So in the number, what we have in the number, we have the byte, short, integer, long, float, and double, as we have in the primitive value. And all of the wrapper classes instances are immutable. So again, they are not like the reference line. So what we have here is the wrapper class and the primitive conversion. How can we convert them? Java provides a number of ways to handle conversions. Common conversions handle automatically, like for example, converting the integer to the integer class, or double to the double class, or for example, integer to the double class, like this. But let's go deeper in it. Suppose that we have a wrapper class like integer. So this is the wrapper class. This is the primitive class. This is the wrapper primitive. This is the primitive. And you want to put the A in the B, that is the primitive. This conversion will be done like automatically. And you want to put the B again into the C, that it is a primitive, and you want to put it in a non-primitive, that is a wrapper. And again, this conversion will be done by Java. So let's just try this. Wrapper class. Okay. So we define an integer and we call it an A, and we'll put 100 in it. Or we define another integer that is primitive, we call it a B, and we put the A in it. And then we define another integer, we call it C, and we put the B in it. There won't be any problem here. Okay. So it's like totally correct. So now let's go a little bit deeper. The primitive to wrapper value, if you want to convert, use your own conversion, you can use on the primitive, you can use the wrapper of the method value of known as a boxing. This method is known as a boxing. Or you can use on a primitive, you can use it like for example, the xxx is the integer or the double or the float, everything. But this technique is known as the unboxing. I will show you some example over here. Suppose that you have an integer that is a wrapper primitive here, and when you want to put 100 in it, there is another way to put 100 in it. It is the integer, and we want to put the value of 100 in this integer. This is a method. This is a way. When you want to put the value of this into another primitive, you can use this xxx value, that is the integer value. Put the integer value of in the e. But here the Java was doing it implicitly. Here we are doing this job explicitly. And then again, we want to use the integer, that value of e, the e value, so it will make an instantiation of integer class, and put that value into this f. Again, this is correct for the float type 2. When you want to put some float primitive value in a float class, wrapper class, you can use just the value of it. And when you want to access the value of this instance, the float value of this instance, you can just use the float value. So let's go a little bit further. There is another type of conversions too, that is the string to primitive, that we can convert. Let's just check this part. I have it in your code. So this is the second way of conversion. Now I want to add b. Okay, b in it. Okay, and put the d in it, and now we have the value. Sorry, we should get here. Okay. There is another way of converting the string to the primitive, and we will use.
Sorry, can you go back?
Yeah, I will. Just let me go for it. I will go back. So we have another string to primitive method. Then we want to change the string to a primitive data. We can use the parse method, and the parse, and after it will be an integer, a float, a double, anything. When we want to take the string value from wrapper class, we will use the value of it. And this is how we do it. We do this. Suppose that we have a string, and the value of the string is like 87.44. And suppose that we want to change this string to a double primitive. So for changing this string to a double primitive, we can use the D here, for example. I'm sorry, the S1, for example, S1. And we will use the wrapper classes extension method, the value of
Move the code up a little bit, Professor.
What?
Could you move your screen up a little bit? We can't see all the code
Scroll
that's
up
showing.
or scroll down.
Can you see it now?
Yeah, thank you.
Okay. And okay, this is the S1, for example, DBL1. So then, again, I want to have the value of S here. The value of S. So I take, so there's two different methods. I can use the parse double, or I can use the value of. I use the value of. Let's now use the double, and DBL1, DBL2 is equal, for example, the double dot parse. Sorry, string. It should be the S dot parse. What was it? Integer. I just forgot it. So it will be from a double. That is the extension method. Yep. This is another extension because in C# is like this. That will be the parse, double parse, I think. Yes, parse double. So here you have again the S. So it will just give the same result to you using the double dot value of a string, or using the double dot parse double value of it. So here it will return a double wrapper. Here it will return a double primitive. This is just they will have some difference in performance. So this will give you a better performance. Okay. So now let's check about using the wrapper classes. What is the usage of wrapper classes? Suppose that you have like many objects, and then you want to put many like multiple objects, and you don't know the nature of that object. So you can use just the object array over here and put anything that you want in that array. This is a hint here. So, and put anything that you want in the array, okay? So I just define an array of a stuff, and the length of it is like 3. And then I put in the first one, I put the flight. In the second one, I put a passenger, and in the third one, I put 100. Okay. So the flight has a toString, is it? So I can just, so I already developed the flight, this toString method for the flight. But what if the flight class is null? If the flight class is null, we should print again something. We should return some string over here. And so let's develop that part first. We go to the flight class, we go to this part, and we will just develop another if statement here. Else if class flight class is, we can use this one. Okay, you can use just that. No, that is not null. And what's happening? Okay, else here. Else if should be like this. That's your problem. Okay, not implied any character. Okay, so as you can see, you couldn't find out what's happening in here. You cannot compare it with a null here because it's not an object, because it's not instantiated from a class. What we should do over here is that, okay, change this values. So we know that we have a wrapper class now. For example, here the integer, and here the character instead of the primitive types. Now, here, instead of checking that if it is more than 0, we just check if it is not null.
Sorry, what did you do with the variables?
I just changed them. I just changed the properties from the primitive type that was an integer with like a
Gotcha.
like small, and now it is capital. Yep. So I just check the null value of the flight number, then check the null value of the class. So this is a leverage that the wrapper classes are giving us. So now so it has some problem because not returning in some part. So return flight identity is not set. Okay. Now we decided about all of the situations that can happen for the flight class now in the toString. So now we have a toString for the flight class. What we want to do is that just do a for. I'm sorry. Okay. Do a for over what? Over the objects. That is the obj. Which object? On the staff. And I want to print them. Would you please print the obj dot toString for me? There are different classes, different variables, everything is different. But now there are else and then okay. That's what happened. You see, the first part, I defined a flight. I didn't assign any flight number or flight class, and I decided to say that okay, the flight identity is not set. But for the second part, we see the passenger doesn't have any toString here. Look at here. Did we develop any toString method here? No way, we didn't. So it will use the embedded toString function that is implemented in the Java. And what is this? It's just saying that, okay, this is an object that is coming from this package. And if you want to know which object it is, you can use this hash code. So this is the hash code. If I just print the hash code of this function, you get here? Okay. Hash code. Each object has a specific hash code, okay? This is the hash code of the flight class. This is the hash code of the passenger class. So this is not the hash code actually. What was it? It was the it was the hash code in the previous version of Java. This is the okay. I don't know what is the mechanism for this now. This is some way that Java knows that which object it is. So it's just using some arbitrary method over here. But you can just find out which object you have in your hand with the hash code 2. By the way, you can just find out which object it is in the console here. I don't know which function it is using now. But previously we were using the same here.
If you change stuff to new integer and pass the value 100, you might get a hash code.
If I change what?
if you change stuff like at index 2 from 100 to new integer value 100, like
I'm not concerning about that part actually. I'm concerning about this part. You know, in the previous version of Java, these two were the same. Okay, but now they changed it, and now they're assigning another thing to it. Like this hash code is different now. Okay, but this is correct, because if you use a primitive type, the hash code and the value of the primitive will be the same. So this is why it is. Yeah, and you are true. You're
I
right.
thought you were talking about 100, not the.
Yeah, I know. So if I change this one to this new integer, it will give me a new integer dot parse int. Like this. Again, it will give me another hash code for that part. Yes, you're right. The problem, the hash code. So you saw what happened in the primitive type, and now this is happening. This will happen for the non-primitive wrapper too. So again, there won't be any hash code over here, because it basically it's a lightweight wrapper class, and it's using the primitive type again. Okay, so what the wrapper classes give us is some leverages. They give us some functionality that we didn't have them in the primitive types. For example, for the numbers, for the byte, short, integer, and long, we have the mean val, max val, bit count, and the two binary string too. So two binary string can be used when you want to send these values on the network. And for the float and the double, we have the mean value and the max value. And we can define, and we can put the is infinite in it, like the infinite in the value of the float and the double. And we can find out that if it is a nan or not. It means that if it is null or not, if it is a number or not, is a number. Okay, so it means that is not a number. Is not a number. If it is not a number, tell me if it is not a number. So the character has another. All of these methods do. It's not a method actually. They are like the constant that we can use them. The mean value, the max value, the is digit method, and the is letter method. So we can just define that if it is the letter and the digit. But if we will use the character primitive, we should do it ourselves. And for the Boolean, we have the true and the false that are the enumeration. You can find all of the documents over here to study more about them. So what we have here is the equality for the wrapper classes. Okay, let's go to the equalities and extension. So the equality, suppose that we have an integer per wrapper integer class, and we define it as 1000 A, and the second 1000 B, and we want just to check the equality of them. Again, because they are not mutable, we cannot use the operator function over them, and we can use the equal function for them. So, so the boxing conversion, again, okay. So the boxing conversion that always return the same wrapper class instance, it will be for the primitive type. It will be the value of the integer again. For the short, it will be the same. And for the byte, it will be the same range of numbers. For the character, it will be from the 0 to the 00FF. That is the hexagonal part of all of the characters that we have in ASCII. And the Boolean will be the true and the false. And suppose that, okay, we are using another integer value that is 8. That is like 4 times 2, that is 8. Again, another integer that is like the 2 times of 2. I'm just thinking that it should be false here again. It shouldn't be true. So it will return again a false over here. So I think that this is enough for this lecture. So I'm going to continue this slides in the next lecture. If you have any questions, just go for it. Otherwise, the class is dismissed.
Can you show the code, please?
Wrap up in this session.
While you're showing the code, so you said push homework 1, push homework 2, and then are we pushing this lecture code too, or?
Yeah, for this lecture, okay, let's in this here. So you should please sign your lectures. Sign your attendance for this time for this lecture, and your assignment for this lecture will be again just duplicating everything that we code in the class, and push your code into the GitHub. So let me check that if you fulfill the attendance here.
I have a question. When are you posting the key for homework 3?
Not now, because you're not graded yet. I didn't put the whole code for it too. So the attendance today is 9. Okay, everyone. And there's so it will be another lab assignment for this lecture again.
And will you push the example code that you wrote today?
Yes, please. Yes, this will be your lab assignment for today. Push. I'm going to push all of the code that I did now into the Git.
Will homework 3 be posted before the weekend?
Probably the grade will be posted. Yeah.
No, I mean the key for homework 3. Since every homework, we updating it, and I was not able to get the output for homework 3.
Yeah, so it should be the there should be the key over there till the weekend, so you can use the key for your project.
Okay.
So it will be the source lecture 11 source, and I commit this.
So you want us to push homework 2, correct?
Yes, please.
Okay.
Okay. So let me just stop the recording so the class is dismissed.